Welcome, I'm Bill Wake. This is my summary of our weekly work on Twitch. Lately, we've been working on a programming language interpreter called 10th, which is an imitator of 4th. And really, it's an excuse for me to learn assembly language on ARM64 and try out a technique called a threaded code interpreter that I've wanted to try for a long time. So this week, we did several things related to the readEval print. First was we extracted a function for Unix read so we could read through the terminal. Second is we have readWord, which breaks up a line of text into the individual words. Third was evalAll, so it's an extension of evaluate that knows about run mode and compile mode. So this is our effort to get the compiler aspect, which is very primitive, but get that working. So it has the notion of meta words that run even in compile mode. So normal words, they run in run mode and they move, they get put in a secondary, which is sort of a routine, compiled into that or gathered into that. And meta words escape that. So words like colon, which is the function definition, it needs to switch you from run mode to compile mode and then do some work on the headers, which we don't do yet. And then semicolon is a meta word that switches us back to run mode. So it's the end of a definition. And so far, that's all we have colon and semicolon doing is going in and out of compile mode, but we'll move beyond that. Okay, so Unix read, we've defined that as a macro, and it takes 3 arguments. The first is the file descriptor, which is 0 for standard in. The second is the address of the buffer memory, where we're going to put the stuff we read. And third is the count. How many numbers do we want to read maximum? And the output is x0 is going to be the number of characters read. So because x0, x1, and x2 are there ready for the service call, we have to tell it which service we want. Number 3 is macOS read, and we make the service call. And then at the end, we do a store byte of a 0, so we end up with a C string. Next is readWord. And, you know, when I make these weekly presentations, I pull in pieces of code, and here I realize, like, wow, this is spreading across 3 screens. Maybe it's a little big, but we have more to put in there, so I know we're going to need to simplify this and abstract it a little. At any rate, the first part of this is we're checking if we're at the end of a line. That's basically the line 40 there we compare to 0, so is it a null byte? If it is, then we're going to print the prompt, which we do in 44, and read a new line. X4 there, line 50, we've defined that as an input. It's a routine you can call through a register. So the register for X4 always points to the read line routine. And we did it that way because of testing. So we don't want to do real read lines in our tests, but we do want to make sure that if you run out of text, it goes and reads a new buffer line and so on. So the X4 approach, put it in a register, is the compromise there. And then finally, X22 is the register that points to the current input buffer. So we have to set that up at the end of a read. Well, it points to the current location as we track through, but when you read, you have to start it back at the start of the buffer, right? Then we do a loop to find, skip any spaces at the front of a word. And this aspect is a little bit new. We weren't doing that a week ago. So if you have dupe space sub, we want to get dup as the first word and then sub as the second. We don't want the spaces included. So when we start looking for a word, we skip over any leading spaces. So if we don't have a space now, we're looking at line 60. We're going to save x0 because that's going to be the return value. It's where we found the start of a word. But we're going to do a check first. We're going to make sure we're not looking at a new line. If we're not at a new line, we'll go forward. But if we are at a new line, we'll skip over that and then go back up to the top where we read lines and see if we can get another line so we get another word to work on. And if we got here, we said, okay, we're at a word, a real word, and we're going to move forward until we find new line or space because we know that's the end of our word. If we find them, we exit. If not, we go back around in 75, back up to 69, and loop some more. And then at the end, we add our trailing 0. X0 will hold our word pointer and will return with that C string. Next, we have our new evaluate routine. It uses the old evaluate we had, which knows how to interpret a word, but evalAll introduces the notion of run mode and compile mode. And so we see in 54 through 56, it's basically trying to determine, are you in run mode or compile mode? So if you're not in compile mode, you must be in run mode, and you're going to go over to 65 on the right. 65 we just set up and then run eval, which is our old evaluation routine we had last week that knows how to evaluate simple words. X0 just sets up to point to the word. If it's not, then down in 58, we're going to say, okay, are you a meta word? If you're a meta word, you're supposed to run anyway. So if you do come up as a meta word, if it returns 1, then we branch over, again, 60, we'll branch over to 65 to evaluate, because meta words always get evaluated. And if we're not a meta word, then we need to be compiled, and we call x23, which is pointer to the function is held in the register, and that function is going to do the compiling. And once we've compiled, which is going to accumulate words into our secondary, we haven't done that yet, we go over to end evalAll and exit the routine. So one way or the other, you either evaluate or you compile. And then finally, we worked on colon and semicolon. So x24 is the mode register. And this assembler is just doesn't have the ability to let us define names, like register names, and give them, some sort of useful name that we can understand. So I have somewhere a little chart that we keep track of what the registers are. But x24 is the mode register. It knows if it's in compile mode or run mode. So we colon enters compile mode and semicolon enters run mode. We don't do the rest. We still need to create and terminate secondaries. So that'll be one of the things we work on next week. Colon is going to create secondary headers. We got to store the string somewhere for the string name, and we don't have string storage yet, so I got to work something out. I think we'll be able to just write it before the header and not worry about it. And then we'll make semicolon close secondaries, and at that point, the compiler is basically done. You have a full end-to-end thing that can create new words, new routines based on other primary and secondary words, and we'll be able to call that and so on. So that'll be the full compiler piece. And then we're down to the primaries. So we've got a handful of primaries now. I think add, subtract, multiply, print a new line, maybe a couple others, duplicate. But we really need to bulk out the language, the whole 10th language that we haven't done yet. So we started off developing an interpreter, and that was the primaries and secondaries. Now we're building this compiler, and as soon as the compiler is there, we're going to build up the primitives of the language. And then I think at that point, you've got a language you can try and use. Now, there's areas we haven't defined yet, notably strings, variables, arrays, plenty of stuff you need to do a real programming job. I think that'll be straightforward compared to developing the interpreter and the compiler. So I'm looking forward to doing that. All right. Well, you can join us Monday through Thursday, 2 to 4:30 Eastern Daylight Time, or 6 to 8:30 p.m. UTC at xp123.com/Twitch is the live version. And if you want the time delayed version, that's at xp123.com/YouTube. You get the old sessions. They're time delayed about 3 weeks and then lightly edited. Well, thanks for listening. Take care. Hope I see you online sometime. Bye-bye.